Welcome to today's deep dive. It's Saturday, February 28th, 2026, and we are absolutely thrilled to have you joining us.
Yeah, thanks for being here. We have a really massive topic on our hands today.
We really do. We're opening up this fascinating stack of research centered around AP Human Geography topic 5.0.
Right, which is basically the study of agriculture and its impacts.
Exactly. And our overarching mission for this deep dive is to explore the ultimate human trade-off. We're looking at how we, as a global society, try to balance this desperate ongoing need for high-yield food production with, well, with the preservation of our planet and the health of our societies.
It's a very delicate balancing act.
It is. Okay, let's unpack this, because when you really stop and look at the sheer scale of the global food system, you realize that agriculture is not just about putting seeds in the dirt. It's a world-building enterprise.
It truly is. I mean, when we talk about farming at the scale covered in this material, we aren't just talking about growing a local food supply. We are talking about a force of nature driven entirely by human hands.
Yeah.
The practices required to feed billions of people literally reshape mountains. They drain entire seas. They alter global economies. And they even change the very roles of men and women within a society.
It's wild. We're going to look at how the simple biological act of trying to feed ourselves has just completely re-engineered both the physical and the cultural landscape of the Earth.
Exactly. The Earth looks the way it does because we eat.
I want to start right there, actually, with the physical landscape. This whole idea of terraforming the Earth just to grow a crop. I was looking through the materials on flash and burn agriculture, and honestly, the imagery is intense.
It's a very visceral concept.
Right, you're talking about cutting down massive swaths of forest and literally setting the remnants on fire just to create an open field. On the surface, it's hard to reconcile the idea of feeding people with intentionally burning down a forest. How is that not just pure, unadulterated destruction?
It certainly paints a violent picture, but to understand the mechanics of it, we have to look at why that fire is so critical. The burning process isn't merely a cheap way to clear space.
Oh, it's not.
No. That fire creates a really thick, dense layer of ash across the soil. And that ash acts as an immediate, massive nutrient boost. It's essentially a natural fertilizer for ground that might otherwise be way too poor to grow anything.
So you're trading the trees for the ash to feed the crops.
Exactly. And at the same time, the intense heat of the fire clears out invasive weeds and destroys local pests and insects that would otherwise decimate whatever you plant there.
So it's like a brutal reset button for the local ecosystem. But how long can a piece of land actually sustain that kind of treatment? I mean, fire's fire.
Well, historically, it was highly sustainable. It's a key component of what's called shifting cultivation, but it only works under one very strict condition.
Which is?
The earth has to be given years, sometimes decades, to fully recover between these burning cycles. Yeah, the farmers would burn a patch, use the nutrient-rich ash to grow crops for a few seasons until the soil depleted, and then they would just move on. They'd allow the jungle or the forest to completely reclaim that original patch.
I see the problem, though, because the material we're looking at points out that modern commercial demand completely eliminates that recovery time.
Right.
The example that really jumps out from the stack is palm oil production in Indonesia.
That is the perfect modern contrast, because the global market demand for palm oil is just so incredibly high. I mean, it's in everything from processed foods to cosmetics. This ancient slash and burn method is scaled up industrially.
And they just do it over and over again.
Yes, performed hastily over and over on the exact same tracts of land.
And the land never gets its decades-long break. The consequences described here are staggering. We are talking about permanent, massive deforestation and incalculable loss of biodiversity, and it even alters local and global climate patterns.
Because you're removing the trees that would normally regulate the environment.
Yeah.
Exactly. The scale of the demand fundamentally changes the impact of the practice. But human ingenuity in farming isn't always about brute force and fire. Sometimes it's this marvel of geographical adaptation. Think about how we approach farming in environments that are completely vertical.
You mean terrace farming. I actually love the visual of this.
Okay.
When you see photographs of these farms, they look like giant green staircases carved right into the sides of steep mountains.
They're beautiful.
They really are.
Oh.
But I always assumed that was a highly specific niche practice.
It's actually a global phenomenon. It's driven by the absolute necessity to utilize every inch of available space. You see massive, intricate networks of terrace farming in Southeast Asia, the Andes, Japan, South Korea.
Wow.
Yeah, entire communities are dedicating generations to cutting flat steps into steep hillsides just to have level plots of land to grow staples like rice.
I'm trying to picture the physics of that, though. If you're carving steps into a mountain in a region that gets heavy rainfall, how does the whole mountainside not just wash away in a massive mudslide the second a storm hits?
That is where the brilliant engineering comes in. By creating these level steps, they don't just create flat dirt, they actively manage the kinetic energy of the water.
Oh, interesting.
When these terraces are constructed and managed correctly, they feature intricate built-in channels. These channels divert rainwater perfectly and slowly from one level down to the next.
So it doesn't build up speed.
Exactly. It ensures every single plot gets saturated without a massive rush of water washing away all the topsoil or ripping the crops out by their roots. It prevents soil erosion and makes an incredibly hostile environment highly sustainable.
That's amazing. We carve up the mountains to control the water, but we are equally determined when it comes to land that already has too much water.
Oh, definitely.
I was reading about the history of draining wetlands. The standout statistic for me in the source material is the Netherlands. 20% of the entire country was once completely underwater.
It's hard to even conceptualize that.
They just looked at the sea, drained it, and said, we're going to plant things here now.
What's fascinating here is how humanity historically viewed those damp, waterlogged environments. For centuries, swamps, marshes, and bogs were considered entirely useless.
Just dead space.
Worse than dead space. They were viewed as diseased, soggy ground that couldn't support the weight of a city and couldn't run a plow. So the logical progressive step for our ancestors was to drain them.
Get rid of the swamp, make a farm.
Right. But modern research gives us a very different understanding of what we actually did.
Because we weren't just drying out useless mud.
Not at all. We now know that wetlands are some of the most critical ecosystems on the planet. When we drained them to make room for agriculture, we destroyed entirely unique habitats that supported highly specialized species.
Right.
But perhaps more critically for humans, we eliminated the Earth's natural water filtration systems. Wetlands act like giant ecological sponges that clean our water supply. We traded essential, irreplaceable ecological filters for a few more acres of arable land.
That is a heavy, almost invisible trade-off. And it ties perfectly into how we manage water elsewhere. I want to shift gears and look at the unintended fallout of how we move water around the planet.
This is where things get a bit grim.
Yeah, we all know plants need water, and if you're farming in an arid, dry place, you have to bring the water to the plants. You build dams, you divert rivers, or you use massive irrigation systems. But the devastation that occurs when we push those systems too far is alarming. Look at the Aral Sea.
The Aral Sea is perhaps the most glaring cautionary tale of agricultural overreach in modern history.
The timeline provided in the research is chilling. Just looking at the data between 1988 and 2008, there was a massive reduction in the sea's surface area. We were talking about an entire sea that practically vanished.
Leaving fishing boats stranded miles out in a dry, dusty desert.
All because we diverted too much of its feeding water to support croplands.
It's a stark visual reminder that water, especially surface water, is not infinite. But irrigation carries another, much more subtle threat that most people never think about until it's too late.
What's that?
Soil salinization.
I saw that term in the notes, soil salinization, and it sounds like intentionally salting the earth. How does watering a plant eventually lead to poisoning the soil?
It comes down to the mechanics of climate and trace minerals. When we aggressively irrigate highly arid, dry regions, we are usually dealing with baking hot temperatures. Farmers pump massive amounts of water onto these dry fields.
Okay, makes sense.
But because the sun is so intense, rapid evaporation occurs. The actual H2O turns to vapor and disappears into the atmosphere. But water isn't purely just H2O. It contains microscopic trace minerals and salts.
Oh, I see where this is going.
Yeah.
So the water leaves and the salt stays behind.
Exactly. And over years and decades of doing this, that microscopic salt accumulates. It builds up into a hard, sterile, white crust right on the surface of the soil, completely stripping the land of its natural fertility.
Wow.
You're trying to water the crops to keep them alive, but the very act of watering them in that specific climate slowly poisons the ground until nothing can grow there at all.
You poison the soil purely by accident. But reading further into this stack, we also introduce toxic elements quite intentionally.
We do.
I came across a statistic regarding the aerial spraying of pesticides, using planes to dust entire fields with chemicals to kill bugs. The research shows that more than 50% of that aerial spray completely misses its intended target.
It's a staggering inefficiency.
Over half. It just catches the wind, drifts away, and indiscriminately coats surrounding areas.
And what goes up into the atmosphere eventually settles. That 50% miss rate leads directly to our next major issue, which is agricultural runoff.
Because it has to go somewhere.
Right. When you apply fertilizers and pesticides at that immense industrial scale, whether by plane or tractor, the excess doesn't just evaporate. When the rain comes, those chemicals wash off the croplands and drain directly into our rivers, streams, and they seep deep down into underground aquifers.
Which means the impact isn't just contained to the farm.
Far from it. That chemical runoff creates massive hazards downstream. It throws aquatic ecosystems completely out of balance, causing toxic algae blooms, and it directly contaminates the drinking water supplies that human populations and local livestock rely on.
It's a perfect example of how interconnected these systems are. You spray a field to kill a beetle, and a river 10 miles away becomes toxic. Let's look at another interconnected system that is currently clashing the tension between transhumance and sedentary farming.
Transhumance, or pastoral nomadism, is a fascinating subsistence practice. It's the practice of people migrating with their herds of livestock based entirely on the seasonal availability of natural forage.
They don't plant fields, they just follow the natural growth of the food.
Yes.
And for thousands of years, that was a highly sustainable way to live. The herds would eat the available grass, and then the people would move them along long before they could permanently damage the landscape. It gave the grass time to grow back.
But the conflict arises when we look at sedentary farming, which is farming in one fixed, permanent place with boundaries and fences. As our global population explodes, sedentary farms have to constantly expand to grow more crops.
They need more space.
And they push further and further into what used to be wide-open, unowned grazing lands.
Which means the nomadic herds are being squeezed out. They're losing their territory.
And that territorial squeeze leads directly to desertification. Because the nomadic herds are forced into smaller, restricted corridors, they can't migrate freely. They're forced to stay in one place for too long.
So the animals overgraze the land.
Exactly, eating every root and trampling the soil until it's compacted. Combined with deforestation, that once fertile grazing land literally turns into a desert. It becomes utterly useless for the nomads and useless for the farmers.
We are just squeezing the life out of the dirt. Okay, let's unpack this. Here's where it gets really interesting, though, because everything we have explored so far is about dirt and water and chemical runoff. But this agricultural technology hasn't just changed the physical earth. It has profoundly changed human culture.
It has fundamentally reshaped who does the labor, what we consume, and who holds economic power.
Yeah.
Let's look at the societal ripples, starting with the role of women in agriculture. This is one of the most massive historical shifts in human civilization. For millennia, across many different cultures and continents, women were actually the primary farmers.
That's wild to think about today.
They were the ones managing the crops, selecting the seeds, and handling the harvests, while men primarily focused on hunting, foraging, or external defense.
That completely upends the modern stereotype of the male farmer on his tractor. What was the catalyst for such a massive cultural flip?
Mechanization. The advent of modern industrial agriculture. When we introduced heavy machinery tractors, mechanical plows, industrial harvesters, farming shifted from manual subsistence labor tightly connected to the household to a massive commercial enterprise.
Oh, and commercial enterprises require money.
Exactly. This new mechanization required capital, loans, and formal land ownership, which historically excluded women. Consequently, men actively displaced women, increasingly taking over the primary farming roles as the systems industrialized.
Wow.
The introduction of a machine didn't just speed up a harvest, it completely rewrote societal gender roles.
A tractor reshaped the social structure of the village.
Yeah.
That is profound. And speaking of ways agriculture changes our daily lives, let's talk about what is sitting in your fridge right now. Because our modern diets are a complete fabrication of global agriculture. The only reason you, as a listener, can walk into a local supermarket in the dead of winter and expect to find fresh, perfectly ripe tomatoes or berries is because of the dual miracles of commercial refrigeration and global shipping chains. We have engineered a constant artificial summer in the produce aisle.
We have, and our expectations for protein have shifted just as dramatically, requiring entire industries to pivot.
How so?
A great example from the research is the major global protein shift that began back in the 1960s. Driven largely by rising medical data and health concerns regarding red meat, we saw global consumer demand pivot sharply away from beef and heavily toward poultry, specifically chicken and turkey.
And you can't just flip a switch to change what animals you raise.
Exactly. The entire global agricultural sector had to re-engineer itself. Raising chickens requires entirely different infrastructure, different feed, and different processing facilities than grazing cattle.
That's a massive undertaking.
Global grain markets had to shift to produce the specific feeds required for this massive new poultry demand.
And re-engineering a global supply chain requires an immense amount of capital, which leads directly into the economic reality of farming today. The materials show an intense trend of economic consolidation.
Yes, the big get bigger.
The nostalgic idea of the small, independent family farm is rapidly disappearing. They simply can't compete, and they are constantly being swallowed up by massive, multinational commercial farming operations.
If we connect this to the bigger picture, this economic consolidation drives a highly controversial practice called monocropping.
Which is just growing one thing, right?
Right. Because these massive commercial outfits are focused purely on maximizing efficiency and scale, they often choose to dedicate vast, endless expanses of land to growing just a single high-demand crop: corn, soy, or wheat, stretching for miles.
It looks like a sea of green.
In the short term, this looks like brilliant economics. It streamlines the machinery, simplifies the chemicals needed, and maximizes immediate profits.
It sounds incredibly efficient on paper. But there has to be a catch to putting all of your resources into a single plant.
It is an incredibly dangerous gamble. By relying entirely on monocropping, massive agricultural economies become terribly fragile.
Because there's no backup plan.
Precisely. If there's a sudden, unexpected shift in consumer preference, a sudden drop in global market demand, or worst of all, a specific blight or disease that targets that one specific crop, you don't just lose a field.
You lose everything.
The entire regional or even national economy can completely collapse overnight. You have literally put every single one of your agricultural eggs into one basket.
So what does this all mean? We are carving up mountains to control water. We are draining the wetlands that filter our planet. We are spraying chemicals that drift into our rivers. And we are relying on giant mega farms growing single crops that could be wiped out by one bad bug. How do we prevent a total ecological and economic collapse while still managing to feed 8 billion people?
That is arguably the most critical question of our era. And the answer, at least in part, lies in a dedicated push toward conservation policies and finding ways to reverse the damage.
We're starting to see a shift, aren't we?
We are seeing a significant global rise in sustainable practices being pushed by governments and environmental groups. Things like returning to crop rotation, which naturally restores nitrogen to the soil without synthetic chemicals.
Well, that's smart.
And a massive push toward organic farming, which is designed specifically to eliminate the toxic runoff we discussed earlier.
And beyond just changing how we farm, there's also direct government intervention to stop farming altogether, which I found totally fascinating in the notes.
Yes, this is a crucial piece of the puzzle.
In the United States, there's a program managed by the Department of Agriculture called the Conservation Reserve Program, or the CRP. The government actually looks at environmentally sensitive land, and they hand the farmers a check to completely remove it from production. They pay them to not farm the land.
And the philosophy behind that policy is incredibly important. It emphasizes a powerful realization sometimes. The most valuable agricultural act a society can take is choosing to do nothing at all.
Just stepping away.
By financially incentivizing farmers to leave fragile, overworked landscapes alone, it allows those damaged ecosystems a chance to breathe and restore themselves naturally. The deep roots of wild grasses return, the soil stabilizes, and the natural wildlife comes back. It is a formal economic acknowledgement that the earth requires a break.
A formal acknowledgement that the earth needs a break. I think that perfectly encapsulates everything we have explored today.
You've definitely covered a lot.
We've covered an incredible amount of ground, from the brilliant gravity-defying terraces carved into the Andes to the tragic, man-made desertification of the Aral Sea. We've traced the massive cold chain journey of the year-round tomatoes sitting in your kitchen, and we've unpacked how the invention of the tractor actively displaced women from their ancient roles as the primary cultivators of the earth. The sheer scale and interconnectedness of our food supply is truly mind-bending.
It touches every single aspect of our daily lives, the stability of our global economies, and the fundamental health of the planet itself.
It really does. So thank you so much for joining us for this deep dive today. The next time you are walking through the brightly lit aisles of your local grocery store, picking out an out-of-season fruit or grabbing a package of chicken, I hope you'll take a second to look past the packaging. You are holding the end result of a massive, world-altering supply chain that literally terraforms the Earth.
This raises an important question, though, a thought to leave you with as we wrap up. We just discussed the luxury of the U.S. government paying farmers to leave sensitive land alone so it can heal.
Right.
But as the global human population continues to rocket toward its absolute peak in the coming decades, and as our farmable land continues to rapidly shrink due to the desertification and salinization we talked about,
Oh, man.
what happens when we can no longer afford to leave any land alone? Will the next great agricultural revolution force us to completely detach food production from the dirt itself? Are we inevitably moving toward a future of lab-grown foods and massive vertical city farms just to allow the planet to survive our appetites?
That is a wild sci-fi reality to ponder. If we ruin the dirt, we have to invent an entirely new way to eat. Keep questioning the world around you. Keep looking for those hidden connections in your everyday life, and we will catch you on the next deep dive.